Okay, guys, so we're going to do some practice of the reactions that we've learned, the addition reactions. I know that this is a different topic than what we were just talking about, but it's really good to go ahead and keep practicing this. Specifically, we need to be able, now that we've practiced some practice problems where we go from the alkene plus our reagents to our product, we also need to be able to go backwards and fill in any blanks given the information that we're told. You will notice mine looks a little bit different than yours. I just decided about 3 minutes ago that I was going to change these slightly. So they should be correct on your paper in front of you. And I just modified my own right here. So fill in the blanks for the following reactions. Take a moment, do these on your own, and I will meet back with you and go through the answers. So this first one here, we have our alkene. And then we have that same alkene is over here in that same position, but now it has an OH added to it. The reason that, or how I know what we're doing in this is that we go from an alkene to an alcohol. So that tells me we're doing a hydration reaction. So we actually also added a hydrogen at this position as well. That means our reagent was H2O, and we needed an acid catalyst to do that. Okay, so that's the answer for the first one. In order to get from that alkene to the alcohol, we needed to do a hydration reaction. This reaction here, we're gonna get, oh, that's not what I wanted. The second question here, we don't know what our reagent is. We don't know what our starting material is. We don't know what's above the arrow, but we have our product and we have that we added HCl. So let's look at this. We know that when we have HCl in a reaction and it makes a haloalkene, that it came from an alkene addition reaction. So let's look at this haloalkane and see what we could have gotten from it. So if we added the chlorine here, that means that a carbon next to it had to have been where the hydrogen was added. If you look, I'm going to erase that circle just so that we can be more clear. If we look at this carbon, there are 3 carbons attached. This one, and this one. Where could the hydrogen have been put? Well, this carbon has 3 other carbons attached to it. There's no hydrogens there. This one's the same. It has carbons all attached. There's no hydrogens there. And that means that the hydrogen added must have been in this position. So we must have added HCl in these 2 specific positions. So my alkene has to be between the carbons in between those. So my answer is going to be the same carbon chain. I'm going to remove the H and Cl and put an alkene. I'm sorry, this is the same carbon chain. There we go. And put the alkene where the HCl was. Then let's look and see what reagent we needed above our arrow. And for hydrohalogenation, we actually don't need a catalyst, so none. Trick question. You're welcome. Okay, and then our last one, we have a halogenation reaction. Nope. Hydrogenation reaction. There we go. Words. And so we start with an alkyne, and we have hydrogenation reaction. We need to put a catalyst for our hydrogenation reaction. So hydrogenations, we know we need a metal catalyst. So you could have put platinum, nickel, or palladium. I love nickel, so I'm going to put nickel in there. I use nickel every day, guys. Okay. And let's see what our product's going to be. So when we do a hydrogenation reaction, we should count our carbons. 1, 2, 3, 4, 5, 6, 7. 7 carbons long. We completely remove our multiple bonds. So I'm going to just draw a 7 carbon chain. 1, 2, 3, 4, 5, 6, 7. So my double bond or my triple bond was between carbon 4 and 5, but now we have hydrogens there from our hydrogen here. Okay, hopefully you guys got those, and that is all we're doing for this practice. You guys will have more practice worksheets to try this stuff out and your online homework to get it down. I'll see you guys later.